Hello, Year 3. Welcome to our Active Planet IPC lesson. Today's date is Monday, the 11th of January. So our learning objective for today is to understand the workings of a volcano. Our key vocabulary today is crater, cone, ash cloud, lava, lateral vent, central vent, and magma. Over the next two lessons, we are going to be looking at volcanoes in depth. By Tuesday, you'll have created a fact file on volcanoes. Firstly, what I want you to think about is what is under your feet. Now, yes, you may have slippers, you may have socks on, you may be sitting in your living room or in your dining room, and you might have carpet under your feet. I want you to think about more carefully what is directly under your feet. So, on your screen, you have got a cross-section of the planet Earth. I want you to have a couple of minutes just thinking about what you know about the planet Earth and what could be underneath our planet or as we go into our planet. So pause the video and have a think. And then when you're ready, I'll continue on with the video and press play. So let's have a look. What is under your feet? Firstly, we have the Earth's crust. Now, the Earth's crust will consist of all the soil, all the dirt that is directly underneath us. If we were to dig a hole in garden, you'll dig up lots of soil, you'll probably dig up lots of rocks, and you can keep on going, keep going further and further down. And you'll notice that the crust is actually a very, very large part of the Earth. It can go down for miles. But underneath the Earth's crust, we have this part called the mantle. Now, you can see on here, it's this sort of orangey colour, and that's because it's molten rock, which means it's like lava, but we call it molten rock, the magma. Underneath the mantle, we go further down to the centre of the Earth, we have the outer core. Now, very, very similar to the mantle, again, it's molten rock, extremely hot. And at the centre of the Earth, we have the inner core. Now, this is more solid. So, the myth that you can actually journey to the centre of the Earth, you definitely cannot journey to the centre of the Earth. It is far, far, far too hot. Yeah, so that's that. Let's have a look at the next slide. So, tectonic plates. The Earth's crust isn't one solid layer. It is broken up into huge areas called tectonic plates that float on top of the mantle. So you can see all these red lines on the globe that we can see here, the atlas. These are all tectonic plates. So what tectonic plate can you see the UK being in? This is our UK right in the centre. Which tectonic plate is the UK on? So we know it's part of Europe, so I can spot the word Eurasian plate there, which kind of makes sense, doesn't it? Because we are in Europe, we're on the Eurasian plate. You can see other sorts of plates as well. You've got the North American plate, Pacific plate, where the Pacific Ocean is, South American plate, where South America is, Antarctic plate, where Antarctica is, and so on. How can you move your plates? So what I would like you to do is to go and get yourselves 2 pieces of paper. Pause the video, and then when you're ready with your 2 pieces of paper, press play. Now that you have your 2 pieces of paper, I want you to lay your plates, the paper, flat on the table. And imagine these 2 pieces of paper are tectonic plates. How many different ways can you move the plates around? First of all, I want you to rub the 2 plates together like this. Next, I want you to move the 2 plates towards each other like this. Think about what happens. Do they slide over each other? Do they sort of meet in the middle? force each other up and then go over each other eventually. And lastly, I want you to move your two tectonic plates away from each other, doing this. Now imagine these tectonic plates are on the Earth's crust. What do you think is going to happen when the tectonic plates move away from each other? Okay, what have tectonic plates got to do with volcanoes? We can see a lovely, beautiful picture here. This valley is over 9,000 years old. It's getting 7 millimeters wider every year as the plates are still moving apart. So you can imagine how long they have been moving apart for. Look at the distance between the two tectonic plates in this picture. And it's called a valley now because our two tectonic plates have moved away, causing this valley in the middle. The rocky valley floor was caused by cooled lava. So we have lava that has cooled, has formed the bottom of this valley floor. So what must have come up these two tectonic plates to cause a valley floor? The valley is surrounded by volcanoes that formed as the plates move apart. So think about what is under the Earth's crust that is going to come up and form cooled lava. Let's have a look on the next slide, hey? So how are volcanoes made? We're going to start on the bottom left. That's our first part. As the tectonic plates move apart, pressure builds up inside the Earth. This then affects the Earth's crust, so that magma can sometimes erupt through it. So as our tectonic plates move apart, we have magma that is being forced up between the tectonic plates where that molten rock is. The lava and ash that has erupted through the crust builds up to form the classic volcano shape over time. And this process is happening all the time. So you can see on this cross section of volcano, we have different colour grey layers. So you can imagine as the tectonic plates have moved apart, a little bit of magma comes up and erupts and forms a first layer to the volcano. Then over time we get another eruption and it forms another layer to your volcano, and eventually it builds up to this cone shape. So what are each part called? Now this top section here is called the eruption cloud. Now this is normally the first sign that a volcanic eruption is happening. There will be an ash cloud, a smoke cloud that is coming out of the volcano. The top part of the volcano is called the crater, where it dips in slightly, very similar to the moon's craters that you can see. Then we have the conduit, which is the main vent. So this is where your molten rock, your magma is coming up through the main vent. At the base, we have a magma chamber that is linked to the layer underneath the Earth's crust. Oh, I think there's one missed off there, sorry. This other main vent, or the vent that's coming off from the main vent, is actually called a lateral vent because it's going sideways. So it's not the main one, it's called a lateral. So sometimes you can have eruptions that come out of the side of the volcano, not always at the top crater of the volcano. So your task for today is to label a cross-section of a volcano. So either draw this diagram or you have the opportunity to print it. I'll leave it underneath this video. And I would like you to label and explain how a volcano is created and grows and what its main parts are called. So already, the diagram is already labelled for you. You may want to add in a label for the other vent, the lateral vent. but you have got 1, 2, 3, and 4 steps to this cross section here. So how is the volcano created? You've got some sentence stems with some missing words you may want to complete. Okay, pause the video to have a go at these, or equally down below you can print off this diagram for you to have a go at home. Good luck. Hopefully tomorrow we'll be looking further into volcanoes and seeing them more in action. Goodbye.